Hello and welcome back in the Sheet Metal Workshop, and in this video I like to show how to make a doom end cap. Okay, well, let's start straight away. I have here a paper in front of me and we're going to start with a sketch. So I'm gonna make a vessel head, a doom end, and therefore I'm gonna first draw one. I have here this template, so that's one side. Okay, so that's my doom end, and I know the diameter is 900 millimeter, and I know this distance is 50. And here is where the weld seam is, and I know here we have a diameter of 100 millimeter. So that's all information I have. So I was on the side, I took the circumference. These are naked sizes, so there's no insulation, and the insulation, it will be 50 millimeter is the insulation thickness. And now we're going to find out what the big radius is, what the small radius is, and the height. Therefore I have a list. So I got here a list, and that's a doom end, and we have here on this list two different types. One we called Korbbogen, and the other one is a klopper. And there's also a third one, that's a dished one. That's also one with really small, it's got the smallest radius from all three. And the Korbbogen is the most highest one. So now you can see in front of me the three types. The first one is the Korbbogen, the second one is the klopper, and the third one is the dished. And I will say the Korbbogen is mostly made, and the klopper, as far as I know, is mostly made out of stainless steel. And the dished one, well, we don't, in the insulation we make then a conical cap or something like that. But for this video now we're going to concentrate on the Korbbogen, and as you can see here the list. The Korbbogen diameter, big radius, small radius, height. That means if I know the diameter, and these three are the formula, that means 0.8 multiplied by diameter is the big radius, and 0.154 multiplied also with the diameter is the smaller radius, and 0.25 multiplied by diameter gives you the height. But these are all inside sizes, so that means the material thickness of the vessel is normally 10 millimeter. But okay, that is here when we start from diameter 1000, and it goes until here on the list on 4000, but as far as I know 8000 are the biggest, and they are also real rare, so you don't see them often. But in what we are going to do is now we're going to calculate now with those formulas, because my sizes are not in the list. So I'm gonna take my calculator, and I want to know the big radius. That means 0.8 multiplied by 900 gives us 720 millimeter for the big radius. So the big R is 720 millimeter. Okay, now the smaller radius is 0.154. 0.154 multiplied by the diameter, that means 900, gives us 139 is the smaller radius. And the height says, okay, 0.25 multiplied by 900 gives us a height of 225 millimeter. So now all information is now there, what we need. So the big radius, small radius, the height, and we got the insulation thickness. We have the naked diameter of 900, and we know from the weld until the end of the radius, where the radius starts, is 50 millimeter. Okay, now we have all the sizes, so let's get started. And first what I'm going to do is I'm gonna make here a working line. Okay, now we have here our 0 point. That's my 0 point, so I'm gonna give a little punch here. So see, so the needle later when I put my bow divider, it won't slip. Okay, so this is the complete line. And next what we know is the big radius is 720 millimeter. Okay, so 720. Yeah, 720, we put it here on the line. And then we mark here. Put the mark, so this distance is 720 millimeter. Okay, now what we also know is the height. The height is 225 millimeter. So that means I already can go from the 720 radius, I go down 225, mark here, and I'm gonna put here an angled line. And what we do next is, I have here a big circle bow divider. So what I'm going to do, I'm gonna put here this one where I marked it. Okay, wait a minute, cap off, and now I'm gonna put it here on the 720 on the big radius. Okay, got it. And now I'm gonna pull a line. So I know the small radius is coming somewhere over here, so I'm gonna make it a little bit longer. So that was the big radius. Now the smaller radius says 139 millimeter. So I can do it here, take here the bow divider. 139. And now I have to find somewhere here on this line where it touches exactly, and then I make here the bow. So here could be a little tricky. Can be happen you miss it. So if you're not sure to do it and you want to do it a more precisely way, well, then it's also an easy method. You just cut a half circle where the radius is 139, and now I'm putting this here on the line and move it forwards until I see, so I'm moving it forwards. Okay, and that touches here. And then I make the line, and I'm gonna hit here another time with the hammer. So I've got a marker over there. Okay, so we check it. This should be my line. So That's my tangent point here. Okay. Next, what we know is we have here on the paper we see diameter 900, so that means a half is 450 millimeter. So that means I go here from my starting point here, 450, and 450, and I just make here the difference. So this should be here, this distance should be then my outside with material thickness, and I have here, well, I will say 8 millimeter. So 8 millimeter I have there. So what I do next, I'm gonna take this bow divider, and because I know it's 8 millimeter, what I do first, I give 50 millimeter insulation. So, almost forgot. So that's my 50 millimeter insulation. And now, taking it from this point in the bow divider on this here, and move it until the line. See? And the same thing I repeat with a bigger bow divider. So put it here, just put it exactly on the line there. And there it is. So that is now my outside, or the circumference of the doom end cap. And yeah, that's where we're now going to continue to make the developing, making the pattern for the doom end. Okay, so next thing, what I'm going to do is, if possible, I measure these sizes. So I have here maybe a better tool. Here, I one side with inches, other side with millimeter. It's also good. So I have here 205 millimeter. And here I have 424 millimeter. Okay, so the next thing is what we're going to do to complete it. We have here this plus 50. So plus 50. I always like to check if everything is still okay, if everything is in an angle. Okay, is so that means that's my doom end now, the side view, the complete side view from here till here. Oh yeah, we had said we have a hole here, diameter of 100 millimeters, so we go 50 millimeter from here. And that's the 50, that makes double 100, so this will give here diameter of a cutout of 100 millimeter. Cutout. So here minus 50 for the template, so that we know how long we're going to cut the template. But before we go there, I forgot something here to mention on this isometric. I thought it was complete, but now we are stuck to it, so I forgot it. I want to make this doom end cap out of 16 parts. So 16 parts, so you can, I always like to make doom end caps where you can divide it in 4, so 16 is easy to divide in 4. It's 90 degrees when it's 4 parts. So, and I want to make 16. That means next thing what we're going to do, you can do it on both ways, or there are 2 ways. That means if I have 90 degree and I want to divide it in 4 parts, that means 23 degree. Okay, my calculator is rounded off, but it's normally 22.5. And then you have to split it again, and then you will get 11 millimeter point 25. So that's if you want to do it with an angle ruler, for example, huh? So normally 11, 10, 11, and here a little bit would be 25. So that means on the other side angle, other side, okay. Here 11. Yeah, so this would be my angle. But we're going to do the classic way. Just gonna make a circle. And if I divide that circle in 2, and make here just to mark it, that will be here. So now I have 2 halves of 45, but I need 4 parts, so no problem, we're gonna divide it again. That will be the next one. Okay, so now I have 1, 2, and then here imagine 3, 4 parts. But for my template, because I'm going to go left and right with my sizes, I need it divided again. So again, 1 time here. Okay. There it is. A longer one, so that means I go from this point here to the center of this one. That should be it. Okay, let's check it. Well, that's pretty good. So, yeah. See, so. Okay, now, what we do next is we're gonna divide this part first, and so it's 424 length minus the 50 gives us a length of 374 millimeter, and I want to divide it every 60 millimeter. That means six times. So what I'm going to do, I take here 60 millimeter in the bow divider, 60, and then I'm gonna go from here, from this tangent point, 60. Okay, so these are now divided, and now I want to divide these 205, but it's enough when I have here a screw, here one in the middle, and here, so it's easy. What we're going to do next is we're just gonna divide this in 2 halves, also with the bow divider. Okay, so that means I'm gonna make here a hole, here, here, and maybe somewhere here. So next thing what we're going to do is we're gonna pull up those lines straight up. Therefore I'm gonna turn my metal around. And take here this one. And we're gonna pull those lines until here where the angled line is. Okay, so now the lines are drawn, and what we do next, because I want to give also swage allowance, and I'm going to give 6 millimeter swage allowance. So 6 millimeter comes here a line. That means now these are now my points. Oh. Okay. That's it. These are now my points. So what I do next is I'm gonna take my calculator again. So 205 plus 424 minus 50 give us 579. See the complete circumference until the cutout. But we have plus 50. So plus 50, 629 millimeter is my outside circumference of my template. Okay, now, I've got the metal. Let's have another check. So see, here you can see it's 629. So what we already know is we have here this 50, so that means I can already scratch here my 50 millimeter from the side. And what I also need is a center line, so I have here 230, so 115 is half. Okay, so that means here that means that bow outside size is 205, so 205 is here, and the middle of it and a half is somewhere here, 102 and a half, so here. And this size should be then 4 to 4 minus 50 gives us 374. So let's have a check. Yeah, 374, here you have it. Okay, so now we go every 60 millimeter. Okay, well, that's it. See, that's that part. Okay, we're good. So what's left is we're gonna drag those points over by, well, you can number it if you want. So I'm gonna turn this around. Okay, so if you want to number it, number 1, 2, 3, 4. So number 3 is the tangent line. 5, 6, 7, 8, 9, and 10. Okay. That means dragging over the points. So this is here number 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is actually 10. Okay. Yeah, so this is the 0, this is the straight part. And that's the same size as here comes. Okay. So dragging over now. Okay. Okay, and we're going to connect here now also these lines. So sometimes some lines are in one line, and that's what we're going to check. So these 3 are pretty much in line. Okay, so I've connected now the lines. So next thing what I'm going to do is I'm going to cut it out by hand. Because if you make a template and you got the possibility to cut it out by hand, I always do it. Because you can more control it by cutting it and you got a real good, nice, perfect cut. Okay, let's speed up. Okay, so now this is now my template. Next thing what I'm going to do, I'm going to take again another bow divider. I'm but then I'm going to take a sharp one, and I'm going to take here 6 millimeters. See, there it is, 6 millimeter, and I'm going to scratch here those 6 millimeter on both sides. And what I'm going to do next is I'm going to punch holes in it. But before I start, I want another hole have here on 25. So okay, so now my template is almost done, or it is done. What we're going to do next, just gonna have a check. And also mark the holes. And now we're going to check if we turn it exactly on the lines, and if you can see the other holes, well, then we are good. And I have to say, this really looks good. So I see everywhere the marker. Don't know if it is possible to see. So here you can see it. Here's another one. So I'm gonna move it here a little bit to the side. Wait a minute. The metal is a little bit too long. But anyway, they are there. So that's a checkup. If you want to check your template, then at least you have to see those holes. Then you'll know you're good. Okay. So next thing what I'm going to do now is I'm going to cut some metal and copy this model for 16 times. So we did the template is done, and I have here prepared some metal. So the next step is what I'm going to do. I'm going to copy over this part 16 times. This metal is aluminium 1 millimeter. So what I'm going to do now, I'm gonna copy first over this template 16 times. Only done 2, so 14 to go, so I'm gonna skip that part. I'm going to finish this in between, and when I've done, we are going to continue. Okay, so now I'm done. This is one metal, so 1, 2, 3, 4, 5 pieces on one. And I have here another 5. And that makes 10. I've got 5 more, that's 15. And I have 2, 16 and 17, but I just leave one just in case. But I don't think I want to need it. So the next thing, let's have a cut. Okay, one left on the metal. And now I have here 16 pieces all cut out. So what we do next, the next step is punching those holes. Now there are different ways to do those holes, and one of them is by punching it. So okay, so I've done now, so it's very time consuming when you do this, but I just want to do it by hand because it's better. So there's also another way, but first I'm gonna punch out a bunch of them, and the last four I'm gonna show a different method with the last four. So 1, 2, 3, 4, and these one I'm gonna punch out now by hand. So I'm gonna also skip this part in the video. Okay, that's it. That was the last one. So I have here 12 pieces already with holes and done. And then I have here also 4 pieces left. I didn't punch out the holes. So what I'm going to do, for example, here, so now it's always in the right position. So what I'm doing now, putting here one on this one, second one, so I have now here 4 pieces. Now, of course, you can make more if you want. So I'm not going to use the template, because if you use the template, it can damage the holes. So therefore, I'm gonna take another segment I already done, and I put it straight so on it. So now as everything is fixed, see. So next thing is I'm gonna put here the vice grip. And I'm gonna okay, so the next step is, when you drill it, it's very important you keep your drill straight. So okay, so that is also an alternative to drill the holes, but you have to cut all your segments very exactly. Okay, so it's done. And now the next part comes is the rounding. We're gonna round that. And then after we're going to swage it and put it together. Okay, now we go to the rounding machine. So I'm gonna do these 4 separate here. And this one, so you can see the difference between the one I've drilled and the one I've punched. So next move is to the rounding machine. Okay, I'm now here at the rounding machine, so just gonna round it here a little bit. So here's where the tangent point is between the 2 radius, so I'm gonna pull it here more up. Then just leave it, and well, this is the form. So let's have a look. Let's have a look. So that means if I round it here, so this is where it is. See, so it must here need a little bit more. Okay, no problem. So a little bit more. Okay, that should be. That's the form. I think it's gonna be good. Okay, so what I'm going to do next is I'm going to continue rounding all those parts in form. See? And also the other ones also I'm going to round, so I'm gonna skip this part also, so I'll round it. Okay. Oh, something gets stuck here, see. Okay, well, that's the last one. So everything is rounded, and the next thing what we're going to do is we're going to swage it and trying to put it together. These are the 4 that I've drilled, and I've set up here with the swage wheels number 0, and I have from the plate until the center of the upper wheel 6 millimeter. Okay, well, let's have a start. Let's see how it goes. Okay, that's one. So let's have another one. So here always a little bit, you pull it a little bit up. Okay, now let's have a first look. Okay. So we can have see here if it is in form. So this is how it should go. Okay. That's the one I'm gonna finish this one up and put 1/4 together. Okay, 1/4 I have put together, so I'm gonna bring it a little bit in form. So, and this is here the part, you know, that's in form. Okay, well, that is the part where I put in with the drills. This is the part I did the hole with the drill. And now I'm gonna take 4 other pieces and swage it. Okay, that's it. Okay. Okay, well, that's the dome end. From the inside, from the outside, and wait a minute. Okay. So that's it. So we have here the whole, see, 100 millimeter, and this diameter should be 900. So just gonna check it. 1 meter. I'm sorry, 900 plus insulation 50 is 1000. So here's 1000, and if I put it like this, okay, that will do. 1 meter. Okay, I hope you liked the video. I mean, it's a lot of work cutting it by hand and do it. So that's it. Doom end. Made a doom end layout complete by hand, and I hope you enjoyed the video. Oh yeah, and if you want to have to put rivets in it, well, I will drill them and then put them in, but you can also modify the template with changing the holes a little bit more, everybody. So if this goes 1 millimeter, that means this distance gets 2 millimeter more, this one gets 3 millimeter more, and this one gets 4 millimeter more. So then you know this is the upper switch, comes over the other, and then it will also do with rivets. Okay guys, thank you for watching. See you in the next video.